Hi everyone, a nice small group here. So the group is so small, feel free to speak up at any point, and we can have this session be more like a BOF and more informal than a big giant room full of people. I'm Steve Northover, client architect and development manager for JavaFX. I have a long history with UI toolkits. I was involved first in Smalltalk, doing UI toolkits, and then in Java. I have a history with Eclipse. I'm responsible for Eclipse SWT, and I left IBM quite a while ago, and I've been working in Oracle for the last maybe 3 or 4 years on FX and other things. So that's me. With me today is my good friend Felipe Heidrich.
Okay, so
Whoa!
that's allowed. Okay, so, I also work on Eclipse with Steve. So I have been building UI toolkits and graphics for over 10 years. I think my first time I worked for accessibility was for Linux, for the ATK support for the SWT. And we started probably in December with accessibility for JavaFX. And we are happy that we were able to complete that in time for ATU 40. And we are about to present you the new API and all the features you're going to get.
Okay, good. This is the useless lawyer slide. I hope there aren't any useless lawyers in the audience. And there's the peanut gallery over there. Back. Get back. We'll make you wait outside. So our table of contents. I guess quickly, there's a very minimal accessibility API that will get you off the ground quickly, and a more advanced version. It's not really 2 APIs, but we like to think of it like that. So let's just move on. What does it mean to be accessible? And here's the definition from Wikipedia. So I'm going to read it out. Accessibility is the degree to which a product, service, device, service, or environment is available to as many people as possible. Accessibility can be viewed as the ability to access and benefit from some system or entity. Accessible software aims to address these things, visual impairments, etc. But the thing that we were addressing most with the Eclipse, with the JavaFX Accessibility API, it's never happened to me before, ever. Not during a talk. Is mostly around visual impairments, and you can see the way to address that is with screen readers and high contrast themes. The zoom capability, etc., is normally built into the operating system, and you don't really have to do much about that. And
JavaFX is already a vector-based graphic engine, so as long as you can use a built-in magnifier, JavaFX is going to look crisp and the graphics are going to look great. So it didn't have to do any work towards that. Mm-hmm. Just given the nature of our technology, we were okay on that sense.
Mm-hmm. So a screen reader, for some of you that don't know, speak the contents of a control, and they have their own concept of focus and traversal that is independent from the JavaFX concept of focus and traversal. And also, each different platform will have different keys to activate that traversal. And those are the 3 examples. Those happen to be the screen readers that the FX Accessibility API supports.
It's the primarily ones that you are officially testing. But any on the Mac, anything Talking as accessible should work with us. But on the Mac, I think is everybody on VoiceOver. On Windows, anyone using
Narrator.
Not narrator. Not the MSAA.
Oh, JAWS. Yeah, JAWS. Anyone who's UIA.
Exactly.
Yeah. So we've implemented the native accessibility, so anybody who speaks that protocol will work with us, or should work with us. Now, it's untested software, and accessibility is very complicated, but these are the ones that we test on and ensure that work. I guess I'm not going to say too much here, other than JavaFX has had several attempts at accessibility, and they haven't come up well in the past. There's been various reasons for that, including turnovers on the team, and plus it's a big, hard problem. And it tends to get addressed at the end of a widget toolkit. Usually the engineers are more concerned, I'm afraid to say, with getting the pixels and getting the controls built on the screen, and then they try and add accessibility as an afterthought, which is obviously not good. But anyway, there was another aspect that kind of caused some trouble, was that Windows itself had a pretty sort of terrible MSAA was a kind of half an API, and a bunch of the screen vendors like JAWS had to implement their own workarounds for how bad MSAA was. And so at the time, figuring out what accessibility API to use for JavaFX was a bit of a problem, because if you use MSAA, there was not enough capability in there to make all of JavaFX widgets be accessible. If you went for a proprietary API, IA2, I'm calling it proprietary. It was an open standard, but it was not supported by Microsoft. So there was API questions, and it was only up until Windows 7 where Microsoft finally got their act in gear and decided to get serious about accessibility and provide an API that was complete enough so that the accessibility vendors like Freedom Scientific didn't have to screen scrape the pixels to understand what strings were drawn there. And it gives me the thumb up. So what really made accessibility so hard? Well, it needs a common portable API, and it has a different implementation way down underneath. So has to have an implementation for Mac and implementation for Windows. There's all these different controls, and they have their own different behavior, and it makes a lot of API to implement to make a control be accessible. So the other thing is that the platform accessibility documentation and the examples they provide were not the best. And Windows normally it does a very, very good job of having a lot of examples about how to use their API. And this is an area where they left a lot of stuff out. In particular, I believe there was not much on the table control.
Yeah, that's correct. It's a very large API, so they had some examples, and the documentation was actually good, but it didn't have the same coverage as other areas like graphics or controls. And Mac was particularly cryptic in that the hierarchy of objects had to be a certain way or the screen reader wouldn't read it. And if the JavaFX hierarchy wasn't exactly the same way, in particular for complicated controls like tables, the screen reader was just not reading it. And none of that's documented, so it was difficult to figure out what was going on and why it wasn't being read. And I guess the last point there is accessibility crosscuts all the way up. So it goes down to the lowest level of the toolkit, which is called Glass. That's the C-based implementation that talks to the operating system. So it goes all the way there, all the way up through controls, up to the skins. And so it kind of crosscuts the whole toolkit. And if you give someone a task of implementing this, they get focused on the lowest level bit. And so this is all kind of a giant excuse why it took us so long to get this API. However, at this point, we have the API, and we're looking good. Okay, so there's two other accessibility implementations around for Java. AWT Swing accessibility is known to be not that great. That's all I'm going to say about it. It requires that you have a extra jar and an extra shared library in this, and it's clunky in that way. Eclipse accessibility is good for the native controls. So as long as you stick to trees and tables that are native in Eclipse, it's pretty good. But when you get farther away from the native controls and attempt to build your own controls that are emulated, then the API has bugs and is not as good. So I guess the takeaway is that the JavaFX accessibility API and implementation is the best, or of the three so far at this point, the most complete. So we had some design goals. We wanted to be complete and minimal. So a lot of the time, accessibility isn't turned on so we didn't want to take up when the screen readers, etc., is not turned on. We didn't want to take up more memory or make anything slower
in that case. So we wanted it to be minimal and complete. We had to implement accessibility for all the built-in controls. So the obvious reason for doing that is so that the controls are accessible, number one. But obviously the second reason is to test out our API, because we're not only implementing the API way down deep in the glass layer and down in the guts of JavaFX, we're using that API to make our controls accessible, and that is a proof of concept that you can use the API to make your controls accessible.
Yeah, another thing I would like to add is that with JavaFX, if you get the 8U40 early adopters build, and you run a little hello world with a few buttons, whatever you throw in there, and you start your narrator or voiceover, it's just going to work. You don't need to install any additional software or do any additional configuration. You just run your application, you turn on your screen reader, it works. There's no other separate download or anything else that you need to install by any means.
So this is just a little diagram that explains kind of very simply that the implementation is a lightweight implementation with a one-to-one mapping between accessible objects that have no state to nodes in a scene graph. Other possible implementations would be to have another hierarchy and et cetera, and that would of course take up more memory, would be another hierarchy to maintain. I'm talking about a runtime hierarchy, not an inheritance hierarchy. Did my screen just do something? Okay. So the key takeaway here is that there's no state in the accessible objects. They are a one-to-one mapping between the nodes in JavaFX. And it's probably about as minimal as you can get. So I guess the talk ain't over, but we've realized our design goals. We're using the runtime hierarchy to talk to the screen readers. We're also using the inheritance hierarchy for our implementation. So node is the root class of a bunch of JavaFX nodes, and every node must have certain attributes associated with it, so we're able to share naturally in the inheritance hierarchy of the classes in JavaFX, right? Right. So if the screen reader is not running, then no accessibility code is getting executed. And that was one of the goals that we had, right?
And when it is running, there is no data duplication, right?
Yeah.
Because if the screen reader needs to read a text, it goes straight at the node, at the very source where that text is stored, and reads it for you. So we don't make copies of we don't duplicate the state.
Duplicated state is a nightmare anyway in software engineering. You don't want to do that, right? It's just keeping things up to date. So just pass
let's switch around now.
Switch around for my intrepid accomplice.
Okay, thanks, Steve. Okay, so we talk about what we want to do and how we want to do it. And I'm going to start by saying that a lot of the heavy lift we have done and put in place for you. So as long as they're using the common controls, I'm thinking about Windows, about our control libraries in JavaFX, accessibility is implemented for those. So we are going to start with that said, you're going to get a lot of things for free, but you don't get everything for free. So there's a lot of simple little cases that we wanted to make it very simple for people using our API. I think the most important in this slide is probably the third one, the text property. When you have an image view or a button that does not have text itself, it's just an arrow pointing left, and that's not enough information. So I will go in details for each one of these properties, but our hope is that by using these 4 to 5 properties, you're going to solve the majority of the problems. Okay, so we're going to start with the role. So for our controls like buttons and table views and links, that's already set, it's already there. If you're going to build your own custom control, you're going to have to set the role for that custom control. So if you implement your own button or your own hyperlink, then you're going to have to start setting these properties. So the first one is really, how we say it here, what is that control, what's the role of that control, and based on that role, the screen reader is going to expect some information to be provided and some actions to be implemented.
like a class, a role is not going to change. So it's not going to be a button part of the time and then a table the rest of the time. It's
right. We don't stop you from doing that, but we don't expect you to do it. So you might actually survive doing that, but it's not really expect. Okay, so this is a little code snippet that is actually the real implementation you would see in JavaFX control buttons. So after the constructor, there's an initialize method that gets called. And in all our controls that I went through, there is one line that we set the default style class. Right after that, I set the role. So if you start browsing, you're going to see all that same pattern happening all through the toolkit, all our controls. So there are two roles that are particularly a little bit different, which is node, which is the basic role. Every element in the UI that the screen reader is going to be interacting with, it is a node or a descendant of a node. The first one down that's important is just a parent. That's nothing but a collection of nodes. Those nodes itself, they make the connections between parent and children, but they are mostly ignored. They don't really carry content information to the screen reader unless you set the role to be something like a button, for example.
So if you think about a hierarchy of JavaFX, like a JavaFX program, it's a large hierarchy of nodes generally, and most of them are containing other nodes, and there's nothing to be spoke for them.
So I think Jonathan's here, and he could probably tell you that our button is aggregation maybe of 3 or 4 different nodes, of which just one probably really matters to the screen reader, right? There are nodes around that are there to put gradients and colors and decorations, but the one that really matters is the one that has the size of it and the one that has the text. Okay, the role description, 99.9% of the time you're not going to worry about this one. When you say it's a button, the screen reader knows to say button. If you're doing something that it's not it, or we're going to have an example at the end to say that's a ball, a arrow, or a chevron, or a diagram, and you want the screen reader to announce that visual element to be such, then that's when you're going to use the role description. When you set that, then you're on your own, and if you need to translate your software to different languages, then you're going to have to do the right thing with that string as well. But if most of the time, let the screen reader go its way, and it's going to just get it right for you.
So the problem was this. The role is an enum, which means there isn't a user-defined role. And the reason it's that way is that is the way it's implemented way down deep on the Macintosh. On the way down deep on the on Windows, Windows has a trait-based API where you can put together stuff into traits. There is a role as well, but it allows you to combine stuff. So when it was time to offer the API, if we'd offered a trait-based API that was similar to what the lowest level Microsoft API is, we would end up trying to implement that on a Macintosh where it's strictly role-based. So we get into trouble. So that's, how we got around that problem.
Okay, so I think I mentioned that quickly at the beginning. So the text property, that's commonly used with an image view or another control that does not have text by itself, but it can be used, it can be set in any control. And in our API, this guy, when it's set, we're going to read that. So it's going to override the text that you see in a table cell or in a button for that matter, or a label. So it has the highest priority. If you play with HTML, it has the alt text. The thing has a lower priority. Or when you have a labeled by, it has which text is going to get it first. This guy gets it in first. And the help, that's usually when you ask the screen reader to give the advanced or more complete information about a node. That's where we're going to go to look for that description, actually help. Usually if you set a tooltip and do nothing else, we're going to go and get the text in the tooltip and use that as the help, like a long advanced description of the node. That we have that on the example as well in the demo at the end of the talk. Label.for, that's also quite important. Usually in a slider, when you have a slider in a UI, it is preceded by a label or by someone else that has the text that is telling you what is that slider controlling. And that's a very common solution, and that's something that the application has to get it right. We will not going to guess it for you in JavaFX. I think we did that in SWT.
Yeah.
In SWT, is that there's a slider and there's no text. We look around for someone with a text, and the preceding guy, if he happens to be a label, we make a free connection there and we give that label. In JavaFX, there is no such a thing. We don't get it for free. So if you have your slider, you gotta set the label by.
Yeah.
So the screen reader has a way to describe what that slider is up to. It's also common when you have a normal form with a label followed by a text input, right? So you have name and text input, last name, text input. So you want to make those connections in your code when you're using JavaFX. Is also good for another reason. The label by has been JavaFX from the very beginning, I believe, and it was used on Windows to activate mnemonic. So it's something that you should already been doing to increase usability of your product, and now it's also important for your screen reader. So, so here I have a little piece of code that will work as I explained. So here is Smith. So when the second text input take focus, it's going to read the label. This editable text, that is the role description that we are getting for free, because we said this text is a text role. And it's editable because it's not, because there's a property for that, and then the value that is inside of the text. Basically the same here, just instead of using a text, I'm using a slider. And the screen reader knows how to make those connections. So as long as you're sending, you're going to get a very good response from your screen reader. Okay, so those are the easy APIs. It's just 5 properties that you should get most of your problems. What I'm going to go in here is really if you are really building a custom control out of not based on anything else. And so this time we're going to allow for the screen reader. Okay, yeah, let's just go to the next one. So you can look at these 3 methods as an interface, but it's not really what it is in the code. Like as I said, everything comes down from Node, and those methods are implemented in Node. So what you have to do, you need to override the appropriate one, or maybe all 3. I'm sorry, except the last one. Yeah. We're gonna override the first and the second, depending what you are doing. And I have examples for that to make
Sorry, Kate, yes, but one way to think about it is, this is too low. One way to think about it is, the screen reader is calling into you, asking for a value, or you're calling out to the screen reader to tell it that something has happened. And the ones that you override are the ones where the screen reader is calling into you. And the one that you don't override is the API where you're calling out.
Right. So moving forward, that's what we're going to see here. Oh, and we have enums. We have 3 enums that are where the API maybe get large. Like if you think that you solve the whole accessibility with 3 methods, it's because you have enums behind and they have a lot of entries in it. I don't know, but maybe 20 or 30, maybe more.
So, yeah, you have your choice of a ton of methods that are custom named and everything, or you have your choice of a generic API with enums to tell you what's going on. So we chose the generic sort of API, not generic in the term of JavaFX generics, but.
Okay. So that's the first one that Steve was mentioning. When the screen reader needs some information, can be the bounds, can be the number of items in the list, the text in a button. It is going to call using the query accessible attribute, and the attribute is going to be accessible attribute is the enum, and that enum has all the possible questions that the screen reader can ask your node. In this little piece of code is the row count. So we're probably doing a list view here, or maybe a table, and it wants to know how many rows are in there. And it's very important that at the end you call super. And that's because in Node is this release is actually not complete. You get a lot of things for free that's already implemented for you, like the state of being focused or disabled, the bounds, the parent, and I actually had to make it short to fit in the slide, but a lot of the work, you don't need to worry about it. Yeah. It's just really about the details of that control that you're doing, and it's usually about 3 or 4 attributes that you need to add.
So you remember I mentioned that we use the inheritance hierarchy of node as part of our implementation rather than having some other hierarchy of accessible button, accessible this, accessible that. So this is an example of inheriting from the root the behavior that you want.
So now we have the other interaction is when the node needs to initiate the communication with the screen reader to tell the screen reader that something is changed in the UI. So the examples I have in here is...
Well, you inverted it.
I inverted it?
You inverted. The actions when the screen reader calls into you and says the thing fired or something happened.
I'm sorry. Yes. This is when the screen reader is telling, let's say, a 3-cell to expand or another, or to activate the button, for example. So this is the case. This is the implement. This is actually the real code that you're going to see in button base that gets all our buttons and hyperlinks in JavaFX. So there's an action called fire, and you just need to tell that button to execute its action. That's what fire is, a public method in a button. I just have to call it. And now is what I was talking about before, is when you need to notify the screen reader that the state of your UI is changed. The most common part is focus node. So the focus is, you're hitting tab or you're clicking around. It needs to know where to go to read. That said, this part is already taken care of for you. You most likely don't need to do anything about that. But value, as you are in a spinner or in a slider, you might have to tell the user that the guy is moving the slider or the 3-cell has been expanded. And so you're going to call the notify accessible attribute with the appropriate accessible attribute.
So remember we were talking about the advanced API, and this is the API that the controls are using to implement accessibility on your behalf. So you'll be interested in these calls if you yourself are implementing a custom control. If you do nothing, you get for free,
Yeah, if you're just using JavaFX, I expect you to get everything or vast majority of your problems solved with those 4 or 5 properties that I talked at the beginning. This is for people that are implementing custom controls.
Yeah.
And here's an example of, I took this code, that's real code again, and I took from the brand new spinner that just went in Java 8 U40, and that's when the value of the spinner is changing, so we use properties for everything, and so we just use the invalidate of the property to tell the screen reader that there's a new value for the... And sometimes the screen reader might not actually use that, but you did your part and you notify the screen reader. In this case, it gets picked up. And there's some decisions that you might want to do based if the screen reader is running or not. For example, like if you have a chart, maybe a chart is not your best option if the screen reader is running. That said, it does work. When you have a chart in your app, all charts are accessible in JavaFX. You can actually read the entire chart by tabbing around all the labels, and it's going to read pretty much all the information that you would have any other way. But you might want to not use the chart. Maybe a table makes it more natural to read that type of data using the screen reader. Or you just want to make the more nodes to be traversable when the screen reader is running, and we're going to show that in the demo. Okay, so I think we are going to start the demo now, right?
Pretty soon.
Okay. That's just how to use this property is up in the platform. So it has you can bind to it. We designed it as a Java property. Okay, so I think Steve wants to go.
Sure, doesn't matter. Whatever.
Sure.
Okay. So this is a short checklist to make your code accessible. Use the standard controls, and you'll be there. The standard controls are highly configurable, so you can generally get them to do what you want. I'm talking about specifically the screen reader. Have a high contrast version for your custom CSS. So if you add custom CSS, have a high contrast version of that available. You need text equivalents for non-text elements. So Felipe was mentioning if you have an image view that's just a picture of something, use the accessible text property to give a short, meaningful description of it. Another thing that people tend to miss is sometimes you'll use an animation like you have something shake like this to indicate an error. Watch for those because somebody using a screen reader is not going to see that happen or may not notice it happen. Label.for, which you should be using anyway, make sure to connect up combos and text fields and I guess sliders and the normal things that get connected in a business application. Make sure that important nodes are traversable. So that's also traversable with the keyboard. So we're going to make a bouncing ball be accessible. So in our world, there's a bouncing ball demo. It's been in JavaFX forever. It's a circle that draws a radial gradient. And by default, it's just a node. So if it's just a node, it means the screen reader ignores it. And so we need to tell the screen reader that the ball is something interesting and we want it to speak its state. So the example code for the bouncing ball, that's the link for it, where it is. And the app looks something like this when we go to run it.
It's part of Ensemble.
Yeah.
If you ever run Ensemble, which is our showcase of some of the features in JavaFX, the bouncy ball is somewhere in there, isn't it?
Okay.
At least once upon a time, I'm sure it was. It's still there? Yeah, okay. Kevin shaking his head, so.
Okay. I'm pretty sure it's still there. So
all right.
let's make sure nothing works. Oh, thank you. What is that? Oh, that's my email. You don't want to see that. All right, let me turn on the screen reader. Come on.
So Steve is going to run the
close button.
Oh, that voice.
Oh yeah. Okay, so here's our bouncing
Eclipse menu 13 items.
I'm betting that it's initial. Let's try that.
Closing menu table row 37 of 67. Java window reset button.
Okay, so now I'm going to tab around, and I'm going to. So there's our bouncing balls.
You are currently on the button. To click this button, press Control+Option+Space.
Yeah, so there's our non-working bouncing ball.
Voiceover off.
So that's a great demo of nothing working. So these are the simple properties that Felipe described to begin with, and we'll set all of them. So we're going to, when you're looking for to make a node accessible, our circle accessible, look for a role that closely matches what the
intent of that control, right? So in that case, we saw that ball, like a thing that you can click, or like a node that you can activate, for that matter. It has some text. I want something to be announced when that's focused, and I want it to respond to an action. So a button was a perfect match in this case.
Right. So we set those 4 properties, and let's try again. Oh, so we don't want this one. We probably want, I'm betting patch 1 is the one we want. Patch 1. So I guess I should turn on.
Voiceover on Java window reset button has keyboard focus.
You still cannot tab, but you can use the commands of the screen reader
currently on the button.
to move over.
To click this button, press Control+Option+Space.
What I gotta do? Do you remember what it is?
I'm going to try. I have not used it with a small keyboard.
First,
here
bouncing ball.
There you go.
So I'm not using the regular traversal mechanism in JavaFX.
You
I'm
are currently on the bouncing ball.
From
To click this button, press Control+Option+Space. The help tag is, this is bouncing ball. Use primary action to start animation.
I worked for 6 months with that going. I had dreams the narrator was on. Anyway, so I'm using a shortcut that's provided by VoiceOver to inspect the UI. I could have used another facilities like make VoiceOver follow the mouse instead of the keyboard, and that would have got me the same.
Second bouncing ball.
But I forgot that shortcut.
Third bouncing ball.
So basically, you actually got quite a bit. You know where you are. You know that the element
You
is
are
a
currently on the
bouncy
bouncing
ball.
ball.
It's the
To
third
click this
one.
button, press Control+Option+Space. The help tag is, this is.
So that's a good example of getting the free traversal.
If you ever work, there is one key that makes it stop talking. Remember that one thing, Control. That's same on Windows as well. I'm showing here on the Mac. Oh, you had to test, right? So, okay. That's the first shortcut to learn. For this demo, it's going to work exactly the same on Windows. The only thing that's going to change are the shortcuts that you're using, but the functionality is going to be exactly the same. So yeah, now I can go everywhere here.
Fifth. Full screen, dim zoom button, close button.
Yeah. So the next patch is just a
You are
small
currently on the close
improvement.
button.
As a
To
matter of
click
fact, you
this
could.
button, which closes the current window. Voice over off.
No. Oh, you got it. Sorry.
Okay.
You have to hit Option, whatever.
I got it.
Function.
As a matter of fact, you could actually stop here. You just set the properties and you already gave a level of coverage here that got you there. But there is something missing that I would like to have. I would like to be able to activate the ball, make the ball bounce. I can use the mouse, so I can actually click in the ball using Notepad, and they will do something not very interesting in this case. But I want to be able to do that.
Go to the slides.
So go back to the slides. Okay,
Yeah,
there's a magic, right?
No, wrong way. Ta-da! Yeah. So there we go. The free native traversal, we've seen this. There we go. We've seen this already. We've talked
The
about
next one.
Right. So we want our ball to be traversed by the tab key, not the free native traversal.
Right. I don't want to have to use Control+Option arrow to go around. So I'm going to add one single line to the constructor of the ball.
Three.
So three to the right or three to the left?
The other way. You'll get too many operating systems if you do that.
Okay. So all the patches, if you actually make those patches available to you, they're very small. The first one was 4 lines of code. This one is 1 line of code.
Get rid.
So it is in my list.
Is it 3, 2? What are we on?
2.
2.
So this is about now. I'm not going to spend a lot of time here,
Java, window.
but I'm just hitting tab,
Reset button.
right? And everything else is pretty much the same.
First bouncing ball.
So I just-
Voice over off.
Now I'm going to go to the last step that's going to provide all the features of this very small app available to the screen reader. Okay, I still don't know how to do it.
Got it away.
Got it. I'm here. So I want to allow the screen reader to tell that ball to start bouncing. And at this time, I'm going to have to subclass that node, which most likely I'm already subclassing anyway. So all I had to do was to add this one method. And when the screen reader says fire, I call the function that starts that animation that gets the ball to bounce up and down.
So this is an example of the screen reader. I have to be onboarded to do this special. The screen reader, and I go the wrong way. The screen reader calling into you, right?
Yes.
And what are
Yeah,
we?
go for it.
What are we on? 3 or
Last one.
is it 3?
Yes.
Okay.
Voice over on Java, window.
Now you gotta
Reset
tell me
button
what
has
to-
keyboard focus. First bouncing
Oh
ball.
yeah, it's option something, right? Yeah.
So instead of
You are currently on
this
the bouncing
demo does
ball.
not
To
have
click this button, press Control.
a key
Option,
handle.
He's talking.
The help tab is this is bouncing ball.
No, let him talk.
No. Actually, we did forget to say that we did provide the help description. If you look at the bottom of this balloon, there's a help tag. So in this one, we said the row to be a button. We said the row description say balloon ball, or it would say button, right? But here,
Second bouncing ball.
so that string ball is your row description. Haven't you said that you would get
You are
what
currently on the bouncing ball. To click
you would get button, because that's the row description that macOS provides for the row. The help tag was also set, and this is a bouncing ball. Use the primary action to activate it. If I can remember the shortcut.
enter search text.
No, I can't.
Enter search text. Previous search. Find menu 81 items. Second
Well, there is
bouncing
one
ball.
shortcut that's going to get you the help.
Command Alt Space, is it?
No, that's to bounce. Okay.
You are currently on the bouncing ball. To click this button, press Control Option Space.
Control Option Space.
Control+Option+Space is going to be the primary action.
Yeah.
So I'm going to get a notification from at the glass level, the very lower level, saying that screen reader called the action, activate primary action. And that goes all the way up to the button.
Press second bouncing ball.
Did I press it? And then that last code is going to run and it's going to start the animation for us.
Press second bouncing ball. Fourth bouncing ball.
And did we miss anything? So we
that's it.
So we got all the properties there.
You are
which
currently on
pretty
the
much-
bouncing ball. To click this button.
which got the majority of the work done. You got one other line to make it easy to traverse around, and you got to implement one method to connect the action.
And that was to make it better. Essentially,
Well, you start with nothing, right? So the first
Yeah.
one actually got you there,
there.
and the rest is just polishing around the corners.
Make you nice. Yeah.
And
I think that's it.
close it up.
All right.
VMware Fusion. Windows 7. Window. Suspend
Thanks a
button.
lot.
Space with VMware Fusion containing Windows 7. Full screen
Go back
space.
to here.
Java. Window. Fourth bouncing ball. Space with applications Java. Eclipse.
Oh, come on. Command, function. F5.
You are currently on the voiceover off.
Thank you. It's actually not a bad. He's a nice guy. I don't mind. And there he is. So that's the final code, and let's stress that it all runs and works on Windows. Just the sequence is different. Summary. Okay. Well, which accessibility API is appropriate? And I mean, I'm saying, it's fundamental and advanced. It's our distinction in the API. There's no real separation, but it's a good way to think about it.
Actually, the first one is implemented on top of the other, right? The properties are using the advanced, if you want to call it that way.
Right, yeah. So 99.9% of the time, stick to the 3-4 properties and you're good. The more advanced API used for custom controls, you may need to use the action. And if you build your application out of standard FX controls, they will all be accessible. And label.for will connect it all together for you.
Right. Goes to say that if you are trying to do like a tree view, it will not be that simple,
Yeah.
right? We kept simple to keep within a time that we had. That said, you can always come to the mailing list or look at the implementation because it's all open source, the code is there. But if that's not enough, we we are here to help you.
I mean, as I mentioned, some platforms, I think Mac, expected your nodes to be in a certain place and things to answer a certain way.
Right.
So, and if you didn't follow, that's not documented on the.
We learn a lot along the way,
So, I mean,
we can help.
yeah. So, summary. Accessibility is here. We're using the native mechanisms. No extra libraries are required. Built-in controls are all implemented. And the API is minimal and complete. And so built-in and also charts, I'm sure we mentioned that, are accessible as well. And that's all. Are there any questions?
You got voice coming out. Is there like an API for voice going in?
So that would be something that Apple would do. There wouldn't be, we would just be on the receiving end of it, and we would be voice activated by Siri or whatever, and that would translate into moving that accessibility focus around next tab, next control or something.
Right. In the case of the bouncy ball, I use a shortcut, but could have been an application that would take that as a voice command and call through the same mechanism with the same final result. But that, as Steve put it, was...
Yeah.
We are, the client would be the server on the other side that would implement such functionality.
The roles like hyperlink and are they part of what the standard set that all the time?
No, we made the rows to match our own names. So the name of the row is the name of the control in our API. It maps to something over there. Yeah.
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 On the Mac.
But the name you see in our API matches our own API. It gets mapped to whatever Mac or Windows decide to call it.
Put a breakpoint inside of get roll and watch the stack, and you'll.
It's going to take some
You're going
time.
to see from Windows and from Mac the call in and what it's asking. Well,
There's a big switch statement somewhere that does this translation.
yeah.
Do you know if Control+FX will be accessible?
They are.
They are?
Oh, yeah, right now. So it was part of the work. It was actually the part that took the most time.
No. Control+FX is the,
the
open
external.
source project.
The open source
Yeah.
code.
Well, I would ask that first.
Yeah.
You have the right guy in the room.
Yeah, I mean, the reason why it's not at the moment is because we don't want a baseline on 8040. So once 8040 becomes our baseline, it becomes a more reasonable thing for us to do. Otherwise, we're going to require everyone that runs Control+X to be running 8040, which is a little bit ridiculous given that 8040 is not out for quite a while. But yes, eventually, once we do baseline on 8040, it's something that we will get around. And
Right.
what we will probably do in the meantime is create a separate branch.
Yeah, I need a branch for that type of work would be interesting.
So,
Having a branch would
Yeah.
make sense.
yeah, we'll have a branch beforehand.
In a place where you're allowed to create branches.
And Bitbucket, already got it.
Yeah.
Is there any kind of story for Linux?
Not at the moment, but the ATK API is also role-based. Remember I mentioned you didn't want to have an API that couldn't be implemented. We didn't want to offer traits. ATK is also role-based, and that's the underlying Linux thing. So it's there's a match there for a Linux implementation. Anybody else? All right, well, thanks a lot, folks. Glad that you came by. It was a nice little group.